Hello everyone and welcome to Kanai's Lab, where tech meets simplicity. Today we are diving into a super fun project using AI to not just detect but track what your pet is doing. Is your dog chilling on the couch, playing on the bed, or following you around? For the demonstration, we are using YOLO, you look only once, one of the most powerful real-time object detection models. YOLO helps identify multiple objects instantly in each frame, making it very perfect for scenarios like surveillance, robotics, and smart homes. So, I use YOLO V8 to analyze how my puppy behaves at home, tracking if he's on the couch or hanging around the room, etc. Simply a camera footage turning into intelligent tracking. Now, let us watch the output video. So the video is here. The label shown in the video is on what he is near or what he is doing. You can see that each and every frame, the object, the dog is located and what he is doing, maybe nearby, or he is roaming, or he is idle, etc. etc. Now, are you curious to see how I built this model? Let's go under the hood for a moment. So here is my Python code. With the help of YOLO V8, I run this. So my video is available in this folder. Let me connect to my Google Drive using the mount function. So I'm mounting my drive now. Once my drive mounting is over, so I will be connecting where the input row videos are located. Next, I need to install the Ultralytics library for taking the YOLO V8 object detection model. Also, I'm taking opencv for Python image processing. So let me take the installation. The installation may take some time. So before that, I just wanted to take you to some other important libraries like YOLO, CV2 for computer vision, and also IM show for displaying the output, also time from the Ultralytics. So I am just loading one at a time. So let's do the process one by one. So what I'm going to do, I'm loading the YOLO V8 model using the YOLO, and this file name is YOLO8n, which is in the PT format. Once the loading of YOLO V8 is completed, we open the video file using cv2.video capture function. And also we are going to fetch the basic properties like width, height, FPS, force, which is going to save as an output by using this video writer function, taking the fetched parameter, what is the output path, what is the FPS, frame per second, width, height, etc. So once this is completed, I'm utilizing or I'm using two helper function. So which is basically before processing it. So I'm taking the one of the function is overlapping and the second one is near. So is overlapping checks if the dog and the another object, maybe like a sofa or a bed or a chair, touching or overlapping based on the bounding boxes. Also is near, which calculate the distance between the dog and the another object to check for the closeness. Maybe you can see here dog near the chair or dog near to the person, etc. So we are going to initializing now. So frame count is equal to 0. So once the initialization, we take the loop. So inside the loop, while true, so we read each frame by using the cap and applying the YOLO model of frame, and extract all object detection like the dog and other furnitures. So we filter the objects by use the confidence function, box.confidence, for every detection. So we check if it is the dog and the store its positions. So we are taking into the dog underscore box, and we do the same for the other objects and store their labels and coordinates. So here comes the core logics. If the dog is detected, so we loop through the other objects and use the helper function. So once the dog is identified, we take the other helper functions to detect the labels. So what condition we are using? If overlapping with the sofa or bed or chair, we are labeling as dog on sofa. Like if near a person or a TV, which is labeling dog near person or dog near TV. Otherwise, default to dog roaming. So this is just a sample demonstration. You may change it according to your idea. So these labels are then drawn on the video frame using OpenCV. So what we are going to do? So we are taking the bounding boxes, then we are putting the text annotation and colors for dog versus other objects. So finally, this annotated for frame is saved and optionally displayed. So we are using out.write, which is taking by the im.show, which is a function again from the computer vision. So this loops runs for a limited number of frames, that's 100, just for the demonstration purpose. So let me run this complete script. So this is going to run now. So it's taking one by one. You can see the output is coming like a frame by frame. So dog on the chair. So it's waiting for the next. It is identifying the objects. So one box is there, one box for the other object, one box for the dog. So this is happening while we running on live. So yeah, that's it. So we tried maximum to track the objects. So if you want to get the full code or try something very similar, so just drop a comment in the below. So I'm happy to share. Yeah, that's it. Your pet is now under AI surveillance. So we can do many other things. It's not only about pet monitoring. You can do similar things like elderly care monitoring or baby room safety, or you can say that smart home automation, maybe retail behavior, etc. So there are a lot of opportunities, though, a lot of potentials is available with YOLOv8 default objects. So thanks for watching Kanai's AI Lab. See you in the next one with more informative content.